So let me start. So today I want to do something related to confidence interval for population mean and proportion. Okay, so you guys already learned about the inference about the population mean in the lecture, and you will learn about the for the proportion, population proportion, maybe next week. But I just put this one because they are very look similar and also pretty much interesting when we think about the case that I put here. Okay. So let me just recap what we did. So last week we have learned about the sample mean follows a specific distribution, which is normal distribution whose mean is population mean, and standard deviation is sigma over square root of n. Okay, and using this fact, what we can do is we can construct a confidence interval for population mean, which is mu. Like our left boundary can be calculated by sample mean, which is x bar minus z score, and sigma multiplied by sigma over square root of n. And n is our sample size. And right hand side, the right boundary can be calculated by x bar plus z score multiplied by sigma over square root of n. So we have two numbers for the CI, and this z value, we call that as a critical value, and that can be determined by our specific confidence level. So popular confidence level will be 90%, 95%, 99%, and we have corresponding z-score, which is 1.6 for 90%, 1.96 for 95%, and 2.57 for 99%. Okay. So what I want to do, I will give you just one example. Okay. Let's say, oh, I want to do. So let's assume that I have one restaurant, and then what I did is I record the percentage of the tips that I get from 20 customers. So I have 20 numbers. And first one is 15.4%, which means my first customer gave me a tip like 15%, 15.4% of his total money that he paid. Okay. And the second one, he got 19.8%. So we have 20 numbers. And what I want to do, I want to figure out the real average of the percent of the tip amount that my customer usually give. Okay, does it make sense? So using these 20, I can construct the CI, confidence interval, for mu, okay, using this formula. Okay, and to use that formula, what should you do first? We need to calculate the yeah, mean, yep, sample mean, right? So for now, you should distinguish from population mean and the sample mean. Okay, so we want to estimate the population mean by using the sample mean. So what is our sample mean here? We need to add them up and then divide by 20, right? So to do that, actually, I want you to use the sets and load the data, and then using the prop means, you can calculate the sample mean. Okay, so just open the sets, and then this is what we have learned when we want to load the data into the set system, right? We declare the name of the data set, and then I just named my variable as a percentage, and then using data line, I can actually just put actual data into the SAS system. Sorry about the percentage in our data. Actually, I need to, maybe I can just get rid of that percentage so that you can use the number itself. But just copy the paste, copy that number, paste into the SAS system, and then just try to load that into the system. Okay? And if you success to load the data, what you can do, you can confirm, I mean, you can print out the data using print procedure, right? Okay. And once you've done that, you will see your data set. So I'll give you just maybe 2 or 3 minutes to do it. Okay. Okay. How many of you got the result here? Anybody having trouble? Yep. Okay. Oh, you get it? Got it. Mhm. So let's just calculate the sample mean then. What is your sample mean? You can calculate the sample mean using this one, prop means, and then set the variable, use the variable. And it will shows you the table which has the information about the observation, number of observation, mean, standard deviation, minimum and maximum. Okay. What is your X bar? So we know that there are 20 data points, and you have X bar as 17.76. Anyone? Anybody? I think the sample mean should be around 18. 18.26. Okay. 18.26. Okay. Maybe you have, Jennifer, what is your N then? Did you get 20 there? Oh, then maybe you should check your data point. So we have 19.26 as our X bar. And then that table shows the standard deviation, which is 3.03, right? Okay. And then what else? We have maximum, minimum, but for now we don't care. And I said we have assumption that I already know the population standard deviation. Okay, in the problem. Okay, so let me just write it down, our formula here. So we have that formula. This is a corresponding table for critical value. So let's say I want to construct the CI with confidence level like 95%. Okay, and then we have the formula for CI, which is X bar minus G star multiplied by sigma over square root of n. And this is my right hand side boundary, G square sigma over square root of n. Okay? And we have calculate X bar here, which is 18.26, right? What is Z score? G star. Alex, you have idea? No? Only 1.96. 1.96, right? We have the table, and then there are, so we have 95%, and then corresponding Z score will be 1.96. Okay? And what is sigma? Sigma will be 3 or 3.03. 3. Okay? So this one came from Stat system, right? This one calculated by 20 data points, which means this is not the population standard deviation. This is sample standard deviation. So I would use symbol S for representing the sample standard deviation, and sigma is our population standard deviation. Okay, in our formula we have sigma, so we should use 3 for that sigma, and then we have 20 for n. So this is my left boundary, and my right hand side I have 18.26 plus 1.96 multiplied by 3 divided by 20. Okay, does it make sense? Okay, so this is my 95% CI for mu, average of percentage of tip that I got. And then actually I can, so what I want to do is just calculate that. So 18.26 will be my X bar, right? X bar. And then next one, I want to calculate the standard error term, which is 1.96 multiplied by my sigma will be 3, right? Divide by square root of 20. Okay, this is my standard error. And confidence interval can be calculated by this one minus that one, right? This is left hand side. Okay, and right hand side, this one plus that one. Okay, so we have left hand, right hand side boundary for confidence interval, and that interval corresponding to 95% confidence level. Okay. Any questions? So far, so good. Okay. So now I want to go back to the formula again. So we have used 3 here, like for sigma, right? But in our real life, that doesn't make sense because the assumption that we already know what is the population standard deviation is unrealistic. So usually we don't have any information about our population distribution, right? So only like closest information that we can use for sigma will be S, like our sample standard deviation, like 3.03, right? So why don't we just use S here? S. Okay. So I can use, if I don't have any information about my sigma, I can use S instead of using that sigma. Then you guys will learn that in this case, we need to use another critical value, which is t, which can be calculated by the t distribution. And in this case, if you're using the t critical value, you will get more wider standard confidence interval for estimating the population mean, okay? Which doesn't make sense because since we have like less accurate information, your estimate for the population mean should be more wider, okay? Because we don't have the confidence level, so my interval should be more wider, okay, to get the same confidence level, okay? So you guys will learn this formula maybe next week, but in SAS, actually we can do it right now by just typing this more option when you're using the prop min. So if you put n min CLM, you will get sample mean, like estimate for the population mean, and then standard, confidence level, 95% confidence interval. So our left-hand side, we have 16.84, and right-hand side, we have 19.67. Okay? So to get the confidence interval, without using the information about population standard deviation, you can do this one. Okay? So that's for inference about the population mean. Okay? And now I want to move on to another topic, but which is really similar to the inference about the population mean. Okay? So now what we want to do, we want to estimate the population proportion. Okay? But so this one, maybe this will be also the future topic. So you will learn about this formula and this topic maybe next week, but I just want you to focus on the formula for now because we want to do more interesting things using this formula. Let's say we have a situation like we have 10 people who got some disease. Okay, all of them has a same disease, and after certain period of the observation time, we have the result that some of them has died from that disease, some of them survived. Okay, so what I want to do, I want to write down 1 if that person have died from that disease, and I will use 0 for the survivors. Okay, so let's say I have 1 0 1 1 0 0 0 1 1 2 3 4 5 6 7 8 9 10. What does this mean? This means how many people we have here? We have 10 people, right? How many of them have died? 4 people, right? Since we have 4 ones, how many people survived? 6, right? So using this data, so this is data, right? Okay. If you want to estimate the death rate of this disease, what did you do? Total number. So it will be 4 divided by 10, right? Okay. And then when you think about, so this is death rate, right? .4, which is 40%. But when you think about this 4/10, I can write it down this way. 1 plus 0 plus 1 plus 1 plus 0 divided by 10, right? Right? So what we implicitly, what you did is just sum them up. You have data, sum them up, divide by number of observations, which is, what is this? What is this? This is sample mean, right? Sample mean of your data, right? So we already know that the distribution of sample mean follows the normal distribution, and then whose mean is actually the population mean. So in this case, let's say, I mean, since we are talking about the proportion, we just using different notation. So maybe this is my estimate for the death rate. So P hat, okay? And then we want to figure out what is the real death rate, which is P, okay? Think about that. And then next week, what you guys will learn is this. So think about, I mean, just consider this P hat is previously X bar, okay? X bar, P hat follows the normal distribution, whose mean is population mean P, and we have different standard deviation here, okay? But you guys will learn about that's actually same, but for now, just take it as granted, okay? So we have different standard deviation, but when we have this formula, over there, what we did, we know that X bar follows this one, so I put this one in here, right? So same thing, same manner. I know P hat follows this distribution, so I just put in here, okay? So same form, P hat minus G score multiplied by standard deviation of that thing. Right hand side, we have P hat plus G score standard deviation for that thing, okay? So same formula. For now, you don't need to understand like how they just get this form of the formula, but I want you to focus on the formula for CI. Okay, so the key point is if you can calculate your p hat, you can construct your CI. Okay, does it make sense? Okay, so we have formula for constructing the CI, and so in the formula actually we have p here. That's unrealistic because the reason why we are doing is actually want to estimate the p. So why don't we just replace p with the p hat? Okay, so this is our final formula. Okay, and so the example that I brought today is actually related to the coronavirus. Have you ever heard about the coronavirus? How many of you? This is like really important topic in including United States and in worldwide. This just generate the really serious problem, right? And personally, I came from South Korea. Um, we have so many people who get disease actually, officially confirmed by government. And I mean, needless to say, the China, right? We have so many people in China who got the disease, and then actually so many people has died from that disease. Okay, so if you click the link in my website, this one, you can go to the website which grab the numbers from many government site, and then make the statistics for each country. So you can right click and then translate that into English. And if you go down. This is the real-time stat for COVID-19. Okay? So first one, it's a China and confirmator, number of confirmator, which means like the number of people who get disease confirmed by government is now 90,000. Okay, 90,573. Okay, among them, 3,042 have died. Okay? And we have 53,000 people get cured from the disease. Okay? And South Korea is second place. We have 6,593 confirmed, and we have 44 deaths and 108 cured. Okay? And if you click the link below to that page link, you can see the article. So WHO is the government which control the disease in worldwide. Okay? They report the death rate of the COVID-19 as 3.4%. Okay, and then the rationale of that number was like this. So he says there have been 90,897 reported cases, and among them we have 3,110 deaths. Okay, so if you divide this number by that number, so 3,110 divided by 90,893, you will get 0.034. So that's why he reported the number as 3.4%. Okay? So this is reported by WHO. And my question is, do you guys agree? No? Yes? And if you agree with that, you should consider the situation, like when we come on. Okay. So when we calculate the death rate of the disease, we'll do this one, right? So we have 10 observations, and then to calculate the death rate of the disease, we count the number of people who have died, and then divide by number of observations we have here. And when you think about this 10, and when you think about these 3, what is the 10 here in this context? $8,573. Do you agree? Anyone has different opinion? Yep. Uh-huh. Mm-hmm. That's actually so what you said is we also think about the like unobserved data, like people who got the disease and then has a mild symptom, they don't go to the hospital, right? So that makes our N become more larger, right? So actually, the President Trump has that argument. So he says that there are so many people who got that disease already, and they don't go to. since they don't have like serious symptom, maybe they have mild symptom, so they don't go to the hospital. So our n should be more larger. So if you consider that fact, it's not like 3.4. It will be more lower than 3.4. So he said that it's way under 1.1%. Okay, so we have two different opinions, and I actually suggest another opinion about the death rate. Okay, so when you think about this situation, let's say I want to add one more number. We have confirmed actually there are 20 people who got disease. Okay, and I saw 10 of them survive and die. Okay, so we have like officially confirmed, oh, this person get cured from that disease. So I have 10 observations, but we have still 10 more people who haven't get the result. Like we don't know whether they will be survive or will be died from that disease, right? So in that sense, even if we have 20 people who confirmed by the government, our real observation, number of real observation will be 10, right? Do you agree? Okay, we have unobserved observation, 10 people here. We don't know. They are still struggling, right? But we have official observation, like we have people who have died from that disease, and we have like officially confirmed that person survived from that disease. So when you think about these three, our real number of observation will be summation of these two. Does it make sense? Okay, so we have 3,042 number of people, and my n will be 3042 plus 53900. Okay, and if you do this, you will get, let's say, so we have 3042 is number of death, and survive will be 53900. So my n should be summation of these two. Okay, so this is my n, and my p hat will be this one divided by my total observation, okay, which is 0.053. So I would say the death rate of the COVID-19 will be 5%, 5.34%, based on the data came from China. Okay, but I think this one is more since China has a lot of observation. This one kind of we can trust that p hat, but more specifically, I can construct my CI because I have p hat and n, and I have formula for CI for population proportion, which is p hat minus z score multiplied by p hat 1 minus p hat divided by n. This is my left hand side, left boundary. P hat plus z score p hat 1 minus p hat n. Okay, And if I want to construct the 95% CI for a real death rate of COVID-19, I can use 1.96 for z-score here. Okay, so let's just do it in here. So what I want to do, I want to calculate this term. Okay, so that one will be 1.96 multiplied by square root of my p hat, this one, multiplied by 1 minus p hat, divided by n, this one. Okay, n is this. Okay, so SE is this standard error. So for left boundary, what I want to do, this one minus this one, right? So my left boundary, this one minus this number, right? And then right hand side, p hat plus that one. Okay. So this is my confidence interval for death rate of COVID-19 with a 95% confidence level. Okay. Does it make sense? So statistically, this interval will capture the real death rate of COVID-19 with 95%. So based on the CI that I have calculated here, at least coronavirus has the 5%, 5.15% of death rate, which is way higher than the WHO's estimate. Okay, and when we think about the like situation where we want to estimate something which can affect the negative impact on our society, I think the overestimate is more safer, right? So maybe we should think about the death rate of COVID-19 should be like 5.5%. Okay. Okay. And also, since we have data for each country, right? Let's say we have United States has 239 get confirmed, and we only have this observation, 30 observation actually, right? Not here. This one. Based on that data, what is your CI? It will be more wider, and it will around actually 50, right? But that's not, I mean, it doesn't mean that the United States death rate of COVID is not 50. That's just like since we have a small number of data, so our estimate for the population proportion will be less accurate. Okay? Does it make sense? So if we have more observation, we can estimate the real peak. Okay, but this is what we can do using basic stat course knowledge, right? To do the real thing. Okay. Any questions? Okay. So some of you might think that there could be a difference between the countries of death rate because some country has a more better facility to treat the disease. So maybe some country has lower death rate than the others. Okay, so if you want to compare the death rate of the two groups, you will do another. I mean, you can use another methodology, which you will learn in chapter 19. Okay, so using that method, you can compare two groups. Okay, so I will keep using this example. So, okay, I think I'm done today. You guys can go. Mhm.